move on to unit number 5. In this, the first half of the unit number 5 is about isometric projection. The name it says isometric projection. Okay, so this is a Greek word. Okay, a word from Greece, that is Greek word. It says iso means equal. Okay, iso is equal, and metric means measure. Okay, that is equal measurement. Equal measurement means a body's measurement is taken equally in all x, y and z directions, so that a complete view of the body can be viewed or seen by a normal an observer or a person. Okay, and this isometric is actually going to give a pictorial view. Pictorial view. Okay, we've already come across this word pictorial view in unit number 1. I have told that pictorial is nothing but picturesque view. If you see a picture of an object, that means you are seeing, suppose you just view your pen or pencil, you could be able to find, observe the whole total body's maybe thickness or length or height or that. It's called pictorial view. So this isometric is that way of one method where you see the total picture of the body. That is the idea. And now here basically you have a 360 degrees in a circle, right? So what is done in isometric view is the 30 degree. See, I have just shown every, say suppose this Q, V and S. I have taken 3 different axes. This it is apart, differentiated apart by 120 degrees each. So 360 degrees totally. So from, if you draw an horizontal line in the center, this 30 degree axis, with this axis, it's called isometric angle. I am going to draw a box with this. Box in the sense, it's called isometric box, right? In which I can, or any observer can draw or see a total picture of any object, which means, see, you have these lines like this. Okay, this is the box. So this is your actually 30 degree line, right? 30 degree you have. So what do you do? Just you bring it down, make a box, this, and from this you can make equal to this parallel, you bring it, and this parallel you can make one more line. This becomes a box now. Easily this one shows a box. So in this box we can draw different types of sketches. Say for example, I want to draw a small, a step. Any step in your maybe a corridor or in your house, or going to the ground floor to first floor. I'll just show it. What do you do? Just I want to draw steps here with some equal, some dimensional value of length and breadth. See, these parallel, these all perpendicular your straight lines, vertical lines, and these are your angle lines. That is 30 degree angle lines. So parallel to each other. This parallel to this and this parallel to this. Now I can draw a just line here, and parallel to this I can make a step here. One more I want, I can make from here. Like, I'm just telling an example of this. I want to draw a circle in this. We have different methods in this. We can divide this box into different values, taking different points, and when you draw a circle, finally you will get like this. Okay, so like this, the purpose of explaining this is to, with the available 360 degrees, only by considering this 30 degree difference, you can construct a box in that any required objects total pictorial view can be drawn and it can be shown. Say for example, I have a rectangle like this. I want to draw the isometric view of the rectangle. What will I do? Simply take this point, you draw a 30-degree line. What to do? Rectangle. These vertical lines, you keep it as it is. Inclined lines, I can do that. Don't bring it there. This becomes a rectangle. Whatever the value is same, if it is 50 millimeters, that is 50 millimeters. There is some difference in scale also. So isometric scale, that some conversion is there. For every value of the actual value, you are going to convert it into isometric scale. There is nothing but you take a point, draw a line. Okay. You say take some 30-degree or 45-degree line. You measure all the values of your original values here. There is a line, and then convert it into, just with the compass you bring it and measure these things. These take these values. Okay, that becomes your isometric scale. That will be told when you are solving a problem. Now, basically, the requirement of this is isometric is nothing but showing the total pictorial view, picture or pictorial view of any object completely by using these 30-degree, I can say, isometric lines. Okay, this is how it starts. So this is useful to identify or observe many objects in different drawings or pipelines or whatever it is. If you take a big big building, the drawings of the pipelines, suppose connected to many corridor or rooms or whatever it is, that can be all shown in different drawing diagrams. That is called axonometric. Axonometric is called axonometric views. Under this is isometric view falls on. This is isometric, and something you have a perspective also. Perspective view. Perspective diagram. So this perspective is your second part of unit number 5. Unit number 5, first part is isometric views. Okay. First we will deal with that, then we will go for perspective. Okay, it is finally to show the total picture of a object completely in x, y, z and 3 directions by constructing a box or without a box, depending on the requirement. Okay. Okay. Now I just told the idea about isometric projection. So it's just we are drawing the total pictorial view of any object with all the x, y, z axis, so that a common man or an observer can see the total picture of any object. That is the idea of isometric views, with the using the 30-degree lines in both the sides, and you can create a box or etc. anything it is, and we often create a box and draw it. It's called box method. Generally to speak, it's called box method. And the simple difference is, normally we take any centimeter length or whatever the common length, it has been converted into isometric length by a conversion 0.82. 0.82 is a conversion data into true length. If you have 70 millimeter, you multiply with 0.82, that value gives the isometric length of particular a line or length or breadth of whatever it is. So either that can be done, or if you want to go one more method, you can just draw a 45-degree line and mark, suppose I want 70 millimeter, 20 millimeter, whatever it is the length, you mark that as it measured from the compass and mark it, and from there next you draw another 30-degree line, okay, from the origin or from the base, and you project everything, all the previous original length points to the 30-degree line. That measured length is taken as your isometric length, or it is called as isometric projection. Okay, and the true length which you are basically taking as original length is called isometric drawing or isometric view. So the view is something and the projection is something. The value conversion is either it's 0.82 into true length, or you can go by this method. That is a combination. Now this is the problem here. Draw the isometric view of a hexagonal prism of base side 15 millimeter, 15 millimeter, and height 35 millimeter. Height is 35 millimeter. When it rests on one of its ends, resting on one of its ends on the HP, resting on HP with two of its base sides parallel to VP. Two of its base sides parallel to VP. This is a question. It is a normal question, and for this as such we want to give what is the draw the front and top views as usual. It's a normal hexagon. It is. You can draw this. So after drawing the hexagon, you just make it a box. So the side of hexagon is given as base 15 millimeter, and the height is given as 35 millimeter. So from you take a 35 millimeter. Okay, then you can just project everything up and mark the points as such. That's it. And these two sketches are basic top view and front views. Then what you do is it is just told when it rests with one of its ends on the HP with two of its base sides parallel to VP. From the base side, two of its sides ends are parallel to VP it is. So we are drawing as such the hexagon in the isometric form. That's it. You have to just construct a box and hexagon should be drawn. So the box can be made in what fashion? I have already told you. This fashion. So you should draw a 30-degree line. Okay. And bottom also 30-degree. And make it equal so that you just construct a box. The box will be made. And from there you can make an hexagon. Okay. Hexagon sense, this can be taken as inner box and outer box also. It comes like this. You have a base. This is the bottom of this, and top is this portion. So it's a prism. Hexagonal prism means both the bottom and top will have a hexagon shape. But so these lines would be again this. As such, it will be created in the top also. To actually draw it in the board will feel difficult because the values of the sides 25 millimeter whatever it should be taken exactly in the sketch. So only the concept is the 30-degree line you have to match it in both the sides and keep drawing. Only by converting this isometric true length you are drawing and required things of 35 millimeter or whatever the 15 millimeter measure it on all the sides you have to just make it like that. So suppose this is your front view. If you see this hexagon in the side view, how does it look like? If you just make a box again, like this. Okay, this one again, it forms a different. Of the 6 sides. So its side will be a different one. So either you make it this method or another one, but by forming the box you have to choose different points, and from there you take the values of given this, what is the value given, is 15 millimeter. Then you take it outside. You can, since your box is formed, you can measure from this point to this point. All this 1, this 2, suppose 3 or 4 or 5 or 6. All these values can be put here, and you can make it 3, 2, 3, 4, 5 and 6 to these points. So this such like this, only the initial placement is as such in the previous problems, and in the box you have to construct just by measuring all these corners from where you have to measure this point, and actually this length can be measured on put in this true length, I mean with this 45-degree line, then bring it down to isometric, that 30-degree line, then that becomes isometric projection. That values you have to measure it. It will be little foreshortened, that's all. Okay, that's how you draw. Okay, and now here's a problem about hexagonal pyramid, right? So draw the isometric view of a hexagonal pyramid of base side 15 millimeter, 15 millimeter, and height is 55 millimeter. Okay, resting on its base on HP with the two sides of the base parallel to VP. It is fine. Now what is the process is now? So basically you are making an hexagon, right, and you are projecting it to the top view, front view. Then you make a box, just close this box, this number it 1, 2, 3, 4. Then other, as usual, you can give, and here since you are making a box here, give number 1, 2, 3, 4 and etc. And you just join all these corners, and these corners can be marked as PQ, PQ, RS, P and U, that's it. Okay. Now just construct a line, I mean just draw a line and make 32 degree. Okay. In this, just make a box with the value of 1 to 2, 2 to 3, 3 to 4, whatever the length, just make it. You take this 1, this 2, probably you have 3 here, parallel to this, and this be 4, 1, 2, 3 and 4. Okay. Then what is next? Now you have to mark these points. Okay. Now the problem is you have to show this midpoint of this value. This 1 and 2 is here. There is P and Q. That you need a midpoint of this line to draw it. Say I take it as M. Okay. This is AR and is available here, and I can go for N here, etc. and U is here. So this value, this point is taken as O. You drop a straight line. These lines are foreshortened lines, inclined lines. You drop a straight line. This is a straight line. So this OM value you mark it here. So this is 30 degree. Fine. This is OM. This distance. This is distance of OM. This distance is that, and this you mark it here, and likewise you mark it for different points, this, and just join this. Again hexagon is here. Okay. Okay. Now how to make it? From this point here, you just drop a line from this M and OM, just from the center point of this, after catching center point, you drop a perpendicular line to the top. Perpendicular top, this and this distance is to be this 55 millimeter height given. This is 55 millimeter. Okay. And this 55 millimeter, this, taking this, you join these points of 1, 2, 3, 4, etc. and the values of P, Q, R, S, T are be made here, and join those points to O top. You will have one more point here and second point also. The main aim is to draw this base with 1, 2, 3, 4, the outer line 1, 2, 3, 4. Then select the center point M point here, and from this M point you draw a line, which is parallel to this 30-degree line, and catch this point, this O. From this you drop a perpendicular line, and that can be joined. That's what makes an hexagon shape. Okay, and whatever you measure from here, 1 to P, see 1 to M you have P, and M to 2 you have Q. So this becomes here PQ, and so it is 2. Then 2 to 3 you have R, PQR. 2 to 3 you have R. Then 3 to 4 you have S and T. You will be having S and T. This you join, you will get hexagon shape. Okay, so that can be properly drawn if you take the, because if this is proper, those values you can measure it and go accordingly. Only thing is this parallel lines and the perpendicular lines should be proper. Okay, that's how you complete the theorem. Only the changes from O to M, this dropped line, that line should be taken from here parallel to this. This length has to be measured here, and you take it and bring a perpendicular and join to all corners. That will, okay.